Hello everyone, welcome back. Today we are going to see Kubernetes deployment. We will see how we write deployment manifest, see how rolling updates are being done, rollbacks and revision. So before we write our manifest, we are going to explain certain things here. So consider this as your deployment. Let's say this is deployment. Then here will be replica set. Here will be our replica set. Then here we are going to have our port. So a deployment is a Kubernetes resource that manages a replica set, and the replica set enables us to define how many port instances we want to run. So deployment creates replica set, and replica set now defines the number of ports we want to create, and inside this port is our running container. So our container runs here. Our container runs inside here. So now inside the replica set here, you can say, okay, let's create or let's define three replica sets, three replicas. So what is going to do is our replica, since we define three replicas here, is going to spin up another port here and another port here. Inside those ports will be one container here, since we said we want three instances of our port. So we have three containers here. So this will be port 2 and this will be port 3. Here is our container. Our container is basically our application running, and here will be our container. So we create another port here and this one. So deployment, our Kubernetes resource that manages replica set now creates all the ports. So if you define two replica sets, it creates two ports that will be running our container. Now here what happens is, if you change the replicas to maybe two replicas, now what is going to do is going to delete one port. Is going to delete one port, is going to delete this port, and you will have only two ports running. So basically that is the flow how Kubernetes deployment function. So now we are going to write our deployment manifest. You can go to your VS Code or any IDE you want. So here, create a file, deployment. It can be any name, but the extension should be YAML. So now first we are going to write the API version, and in order to check for the API version, let's check it from our terminal. API resources, or you'll find for deployment, or anywhere you can just grab the deployment you can just grep for deploy. Okay, here now the version is apps/v1, so let's put apps/v1. Next we are going to put the kind, which resource we want to create, and is the deployment resource we want to create. Now the metadata we want to add. Here we will put the name of the deployment, or the deployment name. Here we are going to use HTTPD, which is Apache, so we can name it as HTTPD deploy, and here we will put annotation. We are going to put kubernetes.io/change course. Here we are going to put here as, let's just say, first official release, and we are going to use this version of HTTPD. Let's just use HTTPD Alpine 3.21. Let's check it from the Docker Hub. We can check first. Let's check it with Nginx. Nginx is still a web server, so let's see if you can use Nginx or Apache or HTTPD. You can use anything. You can use any image you want. The image is basically what we use to create our containers. Let's see if we have any 3.2 here. Let's go to HTTPD. Let's check HTTPD. Alpine 3. I want to use a 3.21 because it's a lightweight image. I don't want heavy ones. Okay, yeah, you can just use the HTTPD, the 3.2. So HTTPD Alpine 3.2. Alright, so yeah, the annotation here is just like a description, because later when we are going to roll out, roll back, we are going to also change our description. Here is to see the version or the release version we are currently on. So let's continue. Here we are going to put the specifications or the specs. Here we will put the replicas. Remember when we were explaining, we said deployment manages replica set, and the replica set now creates the number of pods we want. So here we are going to define 3 replicas. Here then down we are going to select, choose the selector. Here we put the match label as, we put here as app HTTPD. I will explain. Environment as dev. So here is going to use the matching labels in order to know which port to manage. So it's based on the labels. If it finds for a port with a label app httpg environment, there is going how to use that port in order to create it. So now we are going to continue with the template. With the template, then we put here as metadata. We are going to put httpg port. So here now we are defining the port. So this template is a section for the ports. So we put here label. We are going to put the apps or explain the app as httpg and the environment as there. So here, remember I said this matching label is going to check for any label having app and environment. So this is the ReplicaSet part, this is the port part. So it's going to come here and see and check this label and see if there are any labels with app and environment. So we check, then if it finds, it's going to use this port. So it's important to note that this app and this environment should be the same. So this label here should be the same as what is found here in order for it to determine or find the port to use. So after the template, we continue with the spec. Here we are going to put the container. For a name we are going to put as, let's just say, httpg container. The image we are going to use will be the httpg alpine 20. For the port we are going to put as container port, we put 80. This is just for documentation. Now the resources, the limit we are going to put the CPU as, let's just give the CPU limit as 500 and the memory as let's just say 256. So basically the limit here is going to prevent our resources from consuming more than this amount of resources. So we are setting the limit, so don't go above this limit. And here we are going to put as the request, we put request CPU as let's say 250 and the memory as, let's say, 128. So this request is the minimum resource is going to use, so it cannot be below this and it cannot be above this. So check if everything is good, and now we can try to apply it. So kubectl apply -f, the name of the file you want to apply. Good. Now it says deploy created, so we can check get pod. You see that we have our pods that are running. Now let's check for the replica set. See that it created replica set created 3 pods, which is these 3 pods that are running. Let's check now for the kubectl get deploy. Now the deployment has the 3 pods running. Now we are going to check a bit for the annotation, rollout history for the deployment httpd deploy. So here you see that we are the revision is we are at the first official release. We are at the first official release. Let's try to describe this deployment. Okay, here these are all the information on our deployment. You can see the annotation here. This is the first official release. We can see we have our container running. This image. This is the port, and the request the resources is going to use, and the limit is not cross. So now let's make a rolling update. Rolling update means we are going to deploy a new version of an application. For example, if you are running let's say in Unix, here you are running Apache httpd 320. Now we want to deploy maybe a 321. So let's try to do a rolling update. Roll out. First you can come here to check for the command. You can say this is to go back to the previous version. This is to check the status, to restart deployment. Also we want to do a rolling update. So we are going to set the image deployment httpd deploy. The container name is httpd container container. Now we are going to use the Alpine 3.21 because here we saw that we are running the 3.20. Now we want to deploy the 3.21. So the image has been updated, and let's open a new terminal. We will check from here what is happening. kubectl get port. Here is still pulling the image, is checking the image. See if we do not do any error in. Oh, we did an error. So let's is httpd Alpine. That's what is putting the error here. It cannot pull. That's why it's saying that image error, because we did an error in our image. If you check from, if you try to describe it, you see that it's trying to pull. It's trying to pull, but it doesn't see the image. So let's put the Alpine. You see error. Let's put the correct name. Updated. Now see how it is running the containers. It's pulling the containers and is terminating the old container. So if you check now the get ReplicaSet, we are going to see that we have three revisions. We have three ReplicaSets. We have our first ReplicaSet we created. This is the one. The second image, the ReplicaSet it was creating the ReplicaSet with the wrong image name, and this is the third one that we created. So now if you try to kubectl roll out history for the deployment httpd deploy, you are going to see that it's having three revisions, and all of them are having the same annotations. This was the first deployment we had. This is the second deployment we tried to make with the wrong image, and this is the third one we are currently using. But how is the annotation the same? Is because we did not update the annotation after making the rolling update. So we have to kubectl annotate deployment. The name of the deployment is httpd deploy. So here you see that the annotation is Kubernetes change cost this. So we are going to put the same here, kubernetes.io change cost is equals to, here you put second official release, and is using the image httpd alpine 3.21. Good. Now if we kubectl roll out history, try to see the history of the deployment. Deployment httpd deploy. We are going to see now that our third revision, which is the revision deploying with the correct image name, is now second official release. So now if we try to describe the deployment of httpd deploy, describe, I think yes, good. Now we will see that here is the second image, and it's now running our image. Now that was the deployment, the rolling update. So each time we deploy a new image, it terminates the former images, the former ports, and it creates it one by one in such a way that there is no downtime during the update. It doesn't just delete everything and then create other one. It deletes one by one and then create new ones. it creates new ones, then it delete one old port, create a new port, delete the old port, create a new port, delete the old port, until everything is replaced, as you can see from this. So the first one, this was all our ports when we created. This was the wrong image. Now when we deploy the new good image, it terminated everything, the old port. It was saying that it creates new port, then terminates the old port, recreate and run the port. So that is the flow. Now let's see how we can roll back to the previous version. So currently we are running the 3.21. We want to roll back to the previous version. So we can kubectl roll out -s to check. Here you can see that the command is roll out undo. You put the deployment and you put the deployment again. This is to roll back to the previous version. So kubectl roll out undo deployment. Now the deployment name, which is httpd deploy. You can see that it has rollback, and from here you see how yes, it rolled back to the image that was not functioning. So what we want to do is we want to roll back to the image that was functioning. So in order to do that, we roll back to a specific version in this case, because our deployment, our former deployment had an image problem. So if we roll back to the previous version, it's going to cause a problem, because the previous version had an image name that was not correct. So we want to roll back to a specific version, which is the first version. So we are going to put to revision. Here we are going to put revision 1. So now let's check. You see how now is functioning, is rolling back to the first deployment that we created. So if we check now the rollout history of the deployment deployed httpd deploy, we are going to see now that our 5th revision is the first release that we first deploy. So it's important to know that each time you update or you roll back, it creates a revision, and it's with this revision that you are going to change whether you want to go to which version of your application. So we already saw how we write deployment manifest. We saw how we do rolling update. We saw how we can roll back to previous version, and we can roll back to specific version using the revision. So if we try now to get everything, you see that we have our ports running, we have our deployment here running 3 ports, and we have our replica set which is running this one. The other one is 00 because they are former deployment we did. And here in our terminal we were seeing live scenarios or live situation, or what was happening during our rolling updates and our rollback. So thank you for watching this, and see you in the next one.